Hello, today in this video I am going to show you how to deal with constants in linear regression with STATA. So in linear regression, a constant term is always defined by the estimators. If you are having OLS, if you are having two-stage least square, if you are having three-stage least square, the constant term, which is also called as the intercept term, is always calculated by the estimator by itself. But if you want to make changes in your intercept, then how to do this? If so, for that, first of all, let us suppose that I have this data, and in this data, if I am using the two-stage least square, then I have this command. I will use IV regress for this. IV regress to SLS, two-stage least square. I am using my left-hand side variable, which is the dependent variable, is this a long quantity, AP long quantity. Okay, and then my all my dependent variables are written here for the first equation, and after that my independent variable is written here, and after this I have written the instrumental variables. Okay, so in this two-stage least square, if I simply put enter here, then you can see here that the constant is calculated by the 2SLS estimator, and now you have got the results. But if I don't want this constant, if I want to define the constant by myself, then how can I do this? If I let us suppose that I want to create a new constant, okay, and that constant I am generating with the help of generate command, that is gen constant value. I am giving any name, you can give any name. I am giving a name constant value, that is equal to 1 upon is 1 upon, I am having the previous asset, this variable, so 1 upon previous asset. This is the constant which I want to use instead of this constant. Okay, so now how can I do this? If I want to do this, then what I have to do is I have to write the same thing again, but this time I will also write here, after this I will also write my new generated variable, that is constant value. Constant value I have written here, and now with this at the end with a comma I will use another command, that is the command has cons, has constant. So now what is the purpose of this has constant command? Has constant command tells the STATA that there is already a constant present inside, which is already defined. Now what STATA does is STATA will check to make sure a constant is in fact present. If it is not, if it cannot find the one, then it will display an error message. Okay, and calculate the constant value, which is the uh, which is this constant value. It will calculate that value if it does not find any constant present inside. Okay, so now let's see what happens. Here you can see that this constant value, you can't see it here. That is the first thing. And instead of that, your defined constant value is being shown here. It is being shown here, and you can see it here. and there is no constant value which was already there. Now whether you have uh, the value, the constant value which you have given to STATA, that value is relevant or not. For that, what you can do is you can check for it. Okay, so the best procedure is to view has cons command as a reporting option. Okay, estimate with and without has constant and verify that the coefficients and standard errors of variables, they are remaining unchanged. So now here, if you have used IV regress to ls command and you have used the constant value, now you do the same thing here but without this value. Now if you are not using has cons, then what will happen here? Now you compare those coefficients and standard errors with those coefficients and standard errors. Now here if you see, there is almost a negligible difference between the coefficients of this command and coefficient of this command and the standard errors also. Okay, so after introducing this constant value, even if you are not using has cons, then also you are getting the same coefficients and same standard errors in both the cases. It means that this const value, this is a correct constant for this estimation. Okay, so now without const value, you can see here first. Here you can see a lot of difference was there when const value was not there. This const value, when it was not present there, you can see there was a lot of difference. Here it was 17, it was 32, here it was minus 24, it was minus 60, and in the same way here it was 0.911, here it is 3.70, here it is 9.99. So a lot of difference is there in coefficients and standard errors when this const value was not defined. But when this const value is defined, even if you are not using has cons, then also even with this constant which is given by the two-stage square estimator, then also there is no difference. So it means that it is a good constant which is defined and you can use it. Now if you don't want any constant, or means if you don't want any intercept, okay, your mean line should go through the origin, then in that case you can suppress your uh, constant also. And for that, what you can do is you can use the command that is no cons. So STATA defaults to include a constant term, okay, and that constant is the intercept. But if you specify no cons to set the constant equal to 0, if it makes conceptual sense. Okay, now how you can do this? If you don't want this, then this intercept, in that case you write here no cons, and in this case you will not find any constant, and it means that you don't have any intercept and your regression line is passing through the origin. Okay, so in this way you can use, there is one more command, and that is the TSSCONS, and this TSSCONS, it forces the total sum of squares to be computed as though the model has a constant, that is, as deviations from the mean of the dependent variable. But this is a rarely used option that has an effect only when specified with no constant, means no const command. It affects only the total sum of squares and all results derived from the total sum of squares. Okay, so that DSSCOMS command is very rarely used. So mainly we use non-constant command and has constant command, which I have just shown to you. So I hope you like my video. Thanks for stopping.